Hi everyone, my name is Juan Pablo. Welcome back to my YouTube video. In this time we will talk about a feature that is part of the link state protocols, specifically ISIS. And of course, you know that there are two link state protocols available, is OSPF and ISIS. And this protocol, or this feature that is part of the link state protocol, it has become very popular now in service provider environment, and even a few years back, and I would say many years back for all the type of network, for enterprise, for service provider network, it has already been a concern, and a way that how providers or customers or enterprise network can implement this feature in place. That feature is IPv6. Okay, if we look back, for example, 7 years ago, 8 years ago, concerning and centering us into the spectrum of service provider technologies, different type of enterprise or even service providers, when they were creating a greenfield network, they were considering if enabling IPv6 as part of the network implementation, or if they will leave it for later. Of course, IPv4 is a must to have in the network infrastructure. Even 6 years, 7 years ago, it was like that. And they were considering if adding IPv6 on top of that, especially in networks that are having similar service provider technologies like OSPF, ISIS, for example, BGP, Layer 3 VPN, those technologies that are very common in a service provider infrastructure. There are enterprise networks that are acting as a service provider, but obviously in a small size compared to a bigger service providers. A small size, I mean more or less 50, 100, 200 devices in place, composed by provider age and provider devices. So they were thinking how to implement that into their infrastructure, into their IGPs specifically, and even if implementing IPv6. And the service provider, um, some of them had already IPv6 in place. Some of them also were thinking how to implement IPv6 in a brownfield network. Specifically, I would say in a brownfield network, right? How to implement into the IGP protocols, basically. The big motivation for service providers to implement IPv6 is, and you probably are aware, is because SRv6 nowadays. And not only a service provider, also enterprise networks, whenever, especially greenfield, whenever they start to think about the labeling protocol or the transport protocol, obviously SRv6 nowadays is inside of those discussions, even for enterprise network. For service provider network is of course the way to go. I guess I explained in previous videos what might be the reasons to go to SRv6 or not if you have a service provider network, but if not, we will take a look at that in another video. Okay, the point is that if you are thinking to implement IPv6 in your network, either if it's enterprise or ISP, or it's greenfield or brownfield, you have two options. You can enable that into OSPF, or you can enable that into ISIS. Okay, enable into OSPF, it will require that you will need to implement a separate protocol that is OSPF version 3. That for sure is defined. There is no other way to do it, and design discussions ended up right away. But if you have in your option ISIS, that is a protocol very popular in service provider, quite common in enterprise network as well, and I will say hugely adopted in service provider rather than OSPF, then is a table where discussions can come. And there are basically two options to implement ISIS. One option is by single topology, that is what we'll discuss today, and the other option is by enable as a multi-topology. Probably you have heard about these two options already if you look in the blueprint of CCIE service provider, CCD, in any SP related exam of Cisco, you see both in place. And what is those two options? Those two options basically are the way that the core infrastructure in ISIS, the network, treat IPv6. Okay? It's important to realize those two are triggered because you implement IPv6 in your network. That's the trigger for choosing one or another. What is the advantage of single topology? What are the benefits of single topology? And we will expand into that. Single topology basically treats IPv4 and IPv6 as a single address family. Or maybe not single address family, but as a single LSP and eventually as a single SPF calculation. You know that SPF is shorted path first, is the algorithm to calculate the best path for reaching out a particular prefix. So in a single topology, if you implement IPv6, both IPv4 and IPv6 will be considered in the same SPF run. Okay, you will not calculate separate best path calculation algorithm for IPv4, separate for IPv6, but you will run one SPF calculation for both. This is good because it can save you memory in the device. The router just will need to do one process. If you have 1 million prefix for IPv4 and 1 million for IPv6, then you don't need to run twice for both. You run just one. That's one advantage. The disadvantage is that you don't have independency on both protocols. Okay, you cannot run separately IPv4 and separately IPv6, and that might be a problem, as we will see later on. The other option is multi-topology. Multi-topology eventually does what I just explained in a few seconds ago. We run separately IPv4 and IPv6, totally separated in the LSPs and also as the SPF run. Separate SPF run for IPv4, separate for IPv6, totally isolated. They can run individually in your network. You don't need to worry about any problem of running one or another, or configuring IPv6 or not, or configuring IPv4 and IPv6 not. You run both separately. Now, why this is important? I will show you in a diagram. For example, let's imagine that we have router 1, router 2, and router 3. Let's imagine that we run IPv4 and IPv6 in every single link here, IPv4 and IPv6. We have the loopback as well with IPv4 and IPv6. If I have this network in a single topology in ISIS, in a single topology, this will work fine because all the network is IPv4 and IPv6, so they are enabled with both. But what will happen if I remove IPv6 from this link between R1 and R2? If I remove IPv6 and I leave only IPv4, the adjacency will drop down. It will finish. Why? Because in single topology, you must have IPv6 enabled in all the network, in every single link that you establish ISIS adjacency. Because it runs both address family in one LSP and in one SPF run. So if you don't have in one hop, then the adjacency will turn down. Okay, that might be a little tricky. Maybe for a greenfield, it will not be a problem, right? You implement a network from scratch, you realize that this is happening. It's fine, it's greenfield, there is no services. But what will happen if you have IPv4 in place already in the network and you want to enable IPv6 on top? You have a brownfield network and you want to enable IPv6 on top. What will happen is that if you misconfigure in one link IPv6, this link it will go down, and maybe some services are going over there. Maybe you don't have remote LFA or TLFA as your convergence improvement in ISIS. By the way, if you want to see TLFA video, I uploaded a video 2 videos ago, or 2 videos back in my YouTube channel, so I highly encourage you. So if you don't have those fast convergence protocols, then your convergence will be high, even more, right? So in this case, you must have both protocols in place. Otherwise, if you, by any mistake that you implement IPv6, you don't enable in one link, your ISIS for IPv4 will go down, prefixes for that router will not be propagated for that link. If it's the only link, that device will be isolated. If you have segment routing traffic engineering policies using that link for IPv4, it will be not used anymore. If this link is blocked and you have increase of traffic, over the network then that link will not be used for traffic to pass forward. So then it will be isolated. That will cause catastrophic problems in your network, and this is probably something that you don't want. By other chance, if you don't have single topology but you have multi-topology and you remove IPv6, or you didn't configure IPv6 in that link, or you didn't enable that, there is no problem at all. IPv4 runs separately, IPv6 runs totally separately. The adjacency will still be up on that link, it will still be up. ISIS will still be enabled across R1 and R2. The only thing is that IPv6 updates will not be propagated between R1 and R2, because obviously we disable IPv6, so there is no possibility to pass LSPs for IPv6 over that link. But of course, if you are implementing IPv6 into the network as a greenfield, but in a brownfield network with IPv4, then it's not a problem, because your traffic for IPv4 is still going and is still working. Okay, so there is this difference between single and multi-topology. Of course, we mentioned in the beginning the benefit of single topology, that it can save you memory and CPU consumption. But let's be honest, nowadays many devices are very powerful, especially the ones that are in service provider spectrum, like ASR Nike, for example, or NCS. Those devices are very powerful. Running a separate SPF process for the IGP control plane is not probably a problem. For the benefit of this isolation that you have, that's more than compensated. Okay. Another difference is that if you want to, and this is very common nowadays for providers, if you want to move to SRv6 in a service provider that is brownfield, that only have IPv4 and SRMPLS and LDP, for example, in the service provider network, and you want to enable IPv6 as a greenfield for going to SRv6 and later enable SRTE features of SRv6 and so on, be in mind that in single topology, if you have your network as a single topology, your existing network, be in mind that probably SRTE for SRv6 might not work for single topology in ISIS, or might not even have been tested. And even more, when you enable IPv6, you are already combining both address family in the ISIS single topology. So you will be at risk if one IPv6 address is not enabled in place, because it can happen what I just explained a few minutes ago. And you will not keep this isolation that is quite desirable in many service providers, to keep both address families separated. I implement IPv6, I keep all my fast convergence methods and everything for IPv6, and what is existing for IPv4, I still use what is existing without modifying anything. Okay, so this is another advantage. In multi-topology, most of the features for SRTE, for IPv4, segment routing, SRv6 for SRTE is already been tested and is the best practice to go. So that's another reason, if you are planning to use SRv6 or SRTE, always go to multi-topology. Okay. What we will see today in the video is, I have a network that is in the bottom. I have router 1, router 2, router 3. I have IPv4 and IPv6 in every single link. IPv4 and IPv6. I have the loopback 0 in each device, and I have also IPv4 and IPv6 in the loopback. All of that is in multi-topology. Multi-topology is the default method for IOSXR. So if you want to implement IPv6 in the network, by default it will be enabled with multi-topology. You can change to single topology, of course, and we will see that in place. Now, what we will do is, we will verify in the network that is currently in place how it looks with multi-topology. We will change to single topology, but first we will disable IPv6 address into these links. We will remove the IPv6 address specifically in router 1, running multi-topology, and you will see that all the network for IPv4 will still remain in place, the adjacency will be up, and everything will be okay. And we will do the same exercise for single topology. So we will change all the devices to single topology, and do the same test, and we will see that the adjacency will go down, and router 2 and router 3 will lose visibility to router 1. Okay, so that's what we will see today in the lab. Now let me show you quickly how it looks. So for example, now we have ISIS running. I am in router 1 now, P1 in the first device, and it's in multi-topology because it's the default mode. All of this theory of single multi that I just explained start when you enable address family IPv6. Okay, if I take a look in router 2, it also has a multi-topology, and router 2 can see the loopback 0 of router 1, that is here, and also it can see the loopback 0 for IPv6, that is here. Well, here I guess I just missed to... Okay, so I will just fix this because I was doing some tests before, so I missed to get back the configuration. So everything now is with IPv6 and IPv4, and you will see that provider 1 will start see the loopback 1 of P1. It see the loopback 1 because obviously IPv6 is enabling the link, and obviously it see IPv4 as we see here because IPv4 is also in the link. If I type show ISIS database and I focus on the neighbor show ISIS database of P1, for example, what P1 advertised, I put the detail here, you will see that first the flag of multi-topology is in place in the LSP update. And this is because both address families are treated differently and both exist in the network. Okay, multi-topology is in place. And especially here with the prefixes, you will see that IPv4 is in a separate conceptual address family and IPv6 is under multi-topology. Okay, so this gives us an indication that multi-topology is in place and is good. Okay, now what I will do is I will go to router 1 and I will disable IPv6 and I will do commit in multi-topology, and if we go to router 2 and we verify the route to the loopback 0 of router 1 1111 IPv4 is up and we can reach, it's not a problem. But if we check IPv6, we don't reach anymore 2001 : 1. Why? Because the link was disabled from the IPv6 address family. And this is expected, but our address family IPv4 is not disabled. The ISIS adjacency is still in place. If I go to router 3, I see IPv4 yet, because as I said, it's treated differently, multi-topology with single topology, and IPv6 is gone. Okay? So this shows us that multi-topology is trustable. Now, I will just go back the rollback configuration last one. I will get back the IPv6 address on router 1, and I will change to single topology. Okay? How you change? With the simple command show single topology under IPv6. Same here, router ISIS1, address family IPv6, single topology. The same in router 3, all the devices must be in single topology as well. So this is very important for you to know. So all the devices are now in single topology. If I check in P1, for example, to reach loopback 0 of router 1, then it's there. If I check for the IPv6, it's there as well, and it's perfect. All is single topology. I don't have any lack of IPv6 in every link, so it's all good. Now I will do the catastrophic behavior. I will remove IPv6 address from the link between router and router 2. And you will see that the adjacency now will get gone. Now it's still up because you see the whole timer is going super down, 14 seconds, 13 seconds, because IPv6 got broken in the link. So it got broken. It's single topology. It expects an IPv6 address in the link in the LSP updates in every device, but it's not receiving that, so it simply got gone. And we see IPv4 to reach the loopback 0 of router 1 is not in place. We see IPv6 is not in place. We see neighbors is not in place towards P1. And in P1, if we check, it's isolated as well. There is no the neighborship, and of course there is no any routing table in place. And if we check more the ISIS database, this will probably stay for a few time, but then later it will just get, until it reached the LSPH of ISIS, it will get gone. So basically that's the video for today. Guys, I wanted to show you this test for single topology and multi-topology. You see that single topology can be very disruptive if it's not symmetrical end-to-end. Multi-topology is more flexible because both address families are treated differently, and this isolation of address families is what brings the beauty of keeping separate and everything stable if one doesn't exist. So it's to consideration which to enable, and I highly recommend to enable multi-topology because we avoid all these undesired behaviors, especially in a brownfield network for providers. Thank you very much for watching. I hope this video was useful. See you in the next one.